So I will do a couple of the evaluate piecewise function problems, but that doesn't seem to be the area where you guys were struggling. It had more to do with the graphing, the piecewise functions where you guys were struggling. Um, but I want to do a couple of the evaluate ones just for the sake of knowing when to use that undefined button, right? Um, so when we're evaluating, now they're right at my window. Like you could probably see them walk by there. Watch. Did you see them? Like a big blower right outside there. Um, when we're evaluating piecewise functions, when we're asked to evaluate anything in math, they're going to give us some value that we need to plug in. That's all evaluating is. They're going to say, "Hey, evaluate this when x is such and such," right? And in this case, when we look at this, it's saying find f of 4, which means that we're going to plug 4 into x. But we have these three different equations, and we don't have to plug it into all three different equations, right? We have to look at where the parameters allow f to be 4, that x value to be 4. So if I look at this, this one says x has to be less than 1 to use this equation, right? It says when x is less than 1, we would use minus x minus 6. But 4 is not less than -1, right? This one says x has to equal -1. Well, x clearly doesn't, 4 clearly doesn't equal -1. This last one, it says x has to be in between -1 and 3, but 4 also doesn't fall in between -1 and 3. That is when we click the undefined button. That that value that we're trying to plug in doesn't fit any of the rules that go with the equation that we have. We just click undefined. Does that make some sense? So you're looking at these rules that we have over on the side. We've got x has to be less than -1 for this one. X has to equal -1 for this one. And it has to be between -1 and 3 for this one. So anything over 3 is going to be undefined because there's no equation in which the parameters are over the number 3. Does that kind of make sense to you? I'm not seeing any like head nods or shakes in either direction. Jacob, please turn your camera on. All right. Not getting any feedback from you guys at all today. You guys are like, you're killing me here. So let's look at one more of these and then we'll move into the graphing ones because that's where you guys were really struggling. Here we only have two options for what x can be. It could either not equal 5 or it can equal 5, right? There's only two options we have. It's either not equal to 5 or it is equal to 5, which is kind of cool. We can't have anything undefined because all numbers are either going to equal 5 or not equal 5, right? Like I could give you any number and you can tell me it either equals 5 or not equals 5. But it's asking us for f of 5, which means that it does equal 5. So the solution would just be that number. There's no actual equation there. So it would just be 2. So let's see if we, so all these are kind of similar. There's nothing all that big in there. This one, we're looking for f of 1. So we have to look at our parameters. Is 1 between 0 and 3? Yes. So we would use this equation where we would plug that 1 in, right? So in this case, we would take minus x, but x is just 1, minus 3 squared plus 8. And we would go, well, 1 minus 3 is negative 2, right? Plus 8. Negative 2 squared is 4. So we have negative 4 plus 8, which is the same as saying negative 4 plus 8, which just equals 4. And that's how we would determine which one of these equations to use to plug it into. So that's all we're dealing with when we're talking about evaluating. It's just knowing which of those equations to plug it into. But when we get to the graphing pieces, I get level 1 and 2. When we get to the graphing pieces, that's where it seems like you guys were struggling. Those of you that actually started the homework were struggling with that. We're not looking for a number to plug in. We want to graph that line from one spot to another, right? Or those different equations. So the first one, I have x plus 6. That's our first equation, right? And our parameters run from negative 4 to negative 1. It doesn't equal negative 4 or negative 1, but the way I graph a problem like this is I start with negative 4, right? I'm going to start by plugging in negative 4 plus 6, and I'm going to get 2 out. So when the point that I put in is negative 4, the point that I get out is 2. So my x is negative 4 and my y is 2. Then I go to the end number, which is negative 1, and I plug that in. So negative 1 plus 6 equals 5. So when the point x is negative 1, my y value that I get back out is 5. And I can easily graph that right here. I'm going to start at the first point, which is negative 4, negative 4, 2, right? That is this point right here. If you can see my cursor, I'm just holding it down with the mouse right now, and I'm going to take it to the point negative 1, 5. And I just never take my hand off the mouse button while I do that, and I get that line. So you don't see it at first until you start to move it, and then the line will show up. You just have to hold that cursor down the whole time. Or for you guys, like the touchpad, I think is what you guys have on there if you don't have a mouse, that click button. When I go to graph this now, I have to recognize the fact that none of these can be equal. We can't be equal to negative 4, and we can't be equal to negative 1. And if I click those dots, they become open, right? Which means that it can't equal those numbers. If it had that equal sign on it, that line underneath the less than, if it had a line like this under these, then it would be equal to, and we would have closed dots. But minus that, we want open dots. So that covers the graph of that first equation. And so now we have to look at the graph of the next equation, which is minus 2x plus 7. And we know that that's going to run from negative 1 all the way to 5, right? There's no line under the first one, but there is a line under the second one, right? But we're going to do the same thing. We're going to take the beginning point, whoops, this negative 1, and we're going to plug it in. So I have minus 2 times negative 1 plus 7. And so this just becomes 2 plus 7. Negative times a negative is a positive, and 2 times 1 is just 2, plus 7 equals 9. So when we plug in negative 1 for x, we get 9 for y. And we're going to do the same thing now with 5. I'm going to go minus 2 times 5 plus 7. The last one that I graphed, Chris, that one? Okay. You'll see a couple more of them. So once we graph this one, we can go back over, let me graph this equation and then I'll go back over that line too. So I plug in the 5 and I get negative 10 plus 7, right? And I wind up with negative 3. So when I plugged in 5 for x, right, which I got from here, I got a negative 3 out. So I'm going to use these 2 points right here that I just got from plugging it in to graph the next line. So I'm going from negative 1, 9, which is up here. Can you guys see my cursor when I do it? Is it visible on your screen? Yeah? Okay. And I'm going to take it to 5, negative 3. Now, when I plugged in the negative 1, and Chris, the way I found the points is, see how this one starts with negative 1? I plugged that into that minus 2x plus 7 equation, right? And I got out 9. And that's how I got the first point. So when I plugged in negative 1, I got 9 back out. And that's how that point came up. And then I did it with whatever the end point was. And that end point is 5. And so I plugged 5 in where the x was in the equation. And when I filled it all out, I wound up with 5, negative 3. And that's how I get the second point. But and I'll do another one after this. When we look at this, the negative 1 point doesn't have the equal to sign, right? So we want an open dot there. None of these go to infinity. They both have a start and end point. So this is all we need. We've graphed the entirety of this piecewise function. But we'll do more so that you get several examples. And then before I let you go, we'll move into one that has like 3 equations so you can see how that works. But let's look at this one now. And this is being recorded, and I'll put it on Google Classroom so that you can go back and look at them if you need to. So here, when I look at this first equation, it says when it is between negative 6 and negative 3, our y value is just 1. There's no equation with that one, right? What does that mean? That means that from x equals negative 6 all the way to x equals negative 3, the y value is just going to be 1. I don't have to fill out an equation. Everywhere from negative 6 all the way to negative 3, if the numbers fall between there, it's just 1 for our y value. So I do need to look at the fact that it can equal negative 6, but it can't equal negative 3. Negative 6 has that line under it, so that's a closed dot, but this one doesn't. So all we have to do is open dot that. This other part, though, we've got x plus 4 when we run from negative 3 to 2, right? So I'm going to use these 2 points. I'm going to go, well, if x equals negative 3, if I plug it in for that, I get negative 3 plus 4, which is just 1. So when I plugged in negative 3, I got out 1. That's not very legible. Let me make that negative 3 a little clearer. So when I plugged in negative 3 for x, what I got back out was 1. That's my first point. Now I'm going to do the same thing with our end point here, this 2. So when I plug in 2 for x and x plus 4, it would be 2 plus 4 equals 6. So our second point would be 2, 6. And when I go to graph that, I'm going to start at negative 3, 1. That's kind of weird. Because, why is that kind of weird? Because here for this one, negative 3 isn't included. And then this one goes to 2, 6. So where it was open for negative 3 here, it's closed. Oh, no, it's still open. It doesn't equal negative 3 in either one of those, right? But this 2, 6, we've got that line underneath, and so that's going to be a closed dot. So both equations, notice, share this point at negative 3. And then when we hit submit, it should be correct, hopefully, unless I screwed it up. Where did I screw it up? What did I do wrong? Two, 6. Oh, they got it at 3, 6. Why is it at 3, 6? Did I write something down wrong? Oh, did you see what I did? It's supposed to be 2, 6. My point is 2, 6. I just put the point on 3 instead of 2 on accident. It should have been over 1. So that was a graphing error on my part because I knew my point was 2, 6. I just went over a third spot. And errors like that happen all the time when you're graphing. It's why there's no penalty assessed to anything on these. If you get it wrong, you can do it again. You can do another one so that everyone can get 100% when you screw up like I did. I like this problem because this one doesn't have a start and an end point, right? This one, if I look at the first problem, it says we've got 6x plus 11, right? And it says for x less than negative 1. When you have a problem like that, you start with whatever number they give you, right? So for us, I'm going to start by plugging in negative 1 where my x is, right? Which is going to give me negative 6 plus 11, which is just 5. So for negative 1 as an x value, I get out 5. But that just gives me 1 point on the graph. I can put in anything else I want for my second point as long as it's less than negative 1, right? I'm just going to create some other point less than negative 1 so that I can find another point in the graph. And once I do that, I can graph it. So I could pick negative 2, negative 3, negative 4, negative 5, negative 812 million. I'm going to do something relatively close to it, though, so that I know that it fits on this graph that we have. And I'm going to go with, I'll just go with negative 3. Does it matter? No. It just means when I come over here, I'm going to use this equation, and where there's an x, I am going to plug in negative 3, and I get negative 3 plus 11. This gives me minus 18 plus 11, which is just negative 7. Right? So these are my 2 points that I'm going to graph. My first point is negative 1, 5. So here at negative 1, I'm going to go up to 5. And my next point is negative 3, negative 7. This negative 3, negative 7, because it's saying that it's all things less than negative 1, right? That's what we're plugging it in for. we are going to have a point there. We're going to click it once, twice, and it's going to give us an arrow showing us that that will follow that pattern forever, right? For all things less than -1, all values less than -1. The next thing we're going to look at is there's no line underneath this. It's x less than -1, not less than or equal to. So we're going to give it an open dot. So we've graphed our first line, and now we have to graph our second line. And so we're going to do the same thing, but we're going to do it for x plus 6. And our parameters are just x is greater than 2, right? Every number greater than 2. So we're going to start by plugging in 2 for our x value. 2 plus 6 equals 8. So when we plug in 2, we get out 8. And then we're just going to pick some other number that's bigger than 2. Doesn't matter what it is. And we're going to plug that in for x, right? So let's say we want to do 4, right? If I plug in 4 for x, I get 4 plus 6 equals 10. So when I plug in 4, I get back 10, and those will be the 2 points that I use. Our starting point is this 2, 8. So we are going to go 2, 8, and then we are going to go all the way over to 4 and up to 10. But that 4, 10 is just some random point greater than 2 that we put in. So we're going to turn that into an arrow, right, by double clicking it. We don't have an equal to sign here. It's just x is greater than 2. So we want to open dot that one. So when we submit it, we hope I got it right. I always screw up on the graphing because I put things in the wrong spot. Like my eyes aren't what they used to be. But does that kind of flow a little bit better? Does that give you guys a better understanding of what was going on with the graphing? I am going to move to the next level because I want you guys to see what happens when you have like 3 equations in there. This one, notice that this one has a x is either not equal to or it's equal to 2. Those are your only 2 parameters, right? So you're going to graph this equation when it's not equal to 2, which means that you can pop in any 2 numbers that just aren't 2, right? And what's going to happen when x equals 2, when x equals 2, you're just going to have a point at 4. And so that's just a closed circle at 4. Notice you have certain things here now. You have line, closed circle, and open circle. Because sometimes you're just going to have to plot a point if it's just x equals 2. So where x equals 2, it's -4. Let's look at the second part of the top equation on this, though. As long as I have it here, we might as well graph both of them. So we have -2x plus 7 is our equation for anything not equal to 2. So let's go with -6. And so if I'm going to plug in -6, I'm just making up a point, right? 2 times -6 plus 7. If I'm given something where I'm given an equal, like my other equation is like equals 2, I'm going to pick a point on each side of it so I can see the tendency in there. So here I'm going to get 12 plus 7. That was a terrible number for me to choose because that's 19. It's not even on my graph. So I might want to pick something smaller than that. Let's go with, let's pick a different number so it actually fits on the graph. Let's pick 0, right? Forget this -6. Let's pick 0. -2 times 0 plus 7 is just going to give us 7, right? Minus 2 times 0 is 0. So we've got 0, 7 as our first point. And then we're going to pick some other one on the other side of 2. So we could go like 3, right? And if I plug in minus 2, oops, sorry, minus 2 times 3 plus 7, I get negative 6 plus 7, which is just 1. So those are my 2 points, right? There's one on each side. So I've got 0, 7, and I have 3, 1. Oops. Oh, that's why I screwed up. I got to put back the line. I have 0, 7, and 3, 1. What do I know? Here at 2, I guess at 2, I'm going to have an open dot at 2, whatever. I screwed up. 3, 1. Here at open circle, I'm going to go up 2 on my graph, and I'm going to put an open circle there. Because when x equals 2, that's the one spot on the graph of this line that we know is just going to be 4, right? So all of this is true for every point up until 2, which we just put in an open circle because we know at 2 it's something else. And then we can continue it down. Now this one does have a start and an end point, but this one does not, right? This one goes an arrow and oops, dang it. This one's going to be an arrow and this one's going to be an arrow because for every other number other than 2, it's going to follow that line, right? And so you could actually just go, look, you go, okay, well, right here, when x is 7, I can come down here and y is negative 7. Here at x is negative 1, y is 9. And at any point on that line, you can go up and see what the value is in the graph. And we are going to hit submit, and we are going to cross our fingers and hope I didn't screw it up. And I did screw it up. What's the screw up? Oh, the screw up is that I read this as x equals 4, and it actually equals negative 4. See what I mean? Where I screw up the graphs all the time. I'm really bad at following rules. Because x equals negative 4, and I put it up here as x equals 4. Did you see that? I'm screwing up on purpose. It's not that I don't know how to do it. I'm screwing up on purpose just so you guys can see what it looks like when you mess up. But let's look at one where we have 3 equations, and then we will call it a day. So if we look at this first equation, it says when we have minus x minus 3, anytime x is less than 1, right? So we're going to start with x being 1, right? So minus 1 minus 3, and we're going to get minus 4 out of it. And that'll be our first point. And then for our second point, because we can't do a line without a second point, we're just going to pick some number less than 1. Let's go with negative 1. Right? That's less than 1. When I plug in negative 1, and I don't screw up, when I'm plugging in negative 1, that would be minus 1 minus 3, which is just 1 minus 3, which is negative 2. So those are our 2 points for that part, right? For any x that's less than 1, we're going to put in this graph right here. And we're going to go from 1, negative 4, which starts here, all the way to -1, -2. And we're going to make that an arrow because it's for every number, every x value that's less than -1. We're going to open dot this because it's not equal to 1, it's just less than 1. Then we've got this other one that says when x equals 1, the y value is 2. So here at x equals 1, we know we're just going to have a dot for 2. Then we're going to go to this last equation. We've got 6x minus 7 for all x is greater than 1. Oops. So again, we're going to start by plugging in 1, right? That'll be our first point when x is 1. And then we'll plug in some point that's greater than 1. So let's call it 3, right? But let's start with the 1. 6 times 1 minus 7 is just 6 minus 7, which equals -1. And then we're going to do the same thing with this 3 point that we're choosing. So 6 times 3 minus 7. I'm probably going to wish I'd chosen 2, but that's going to give us 18 minus 7, which is 11. I'm going to go for 2 just so that I can keep it on the board. So if I have 6 times 2 minus 7, that becomes 12 minus 7 equals 12 minus 7 equals 5. That works a little better for us because my screen, my graph only goes to 10, so I just wanted to keep it as a smaller problem. So for this one now, we're going to do our 1. We're going to graph this point, and we're going to graph this point, right? Because I changed that one because it didn't fit in my graph. So we've got a point at 1, -1, and it's going to go to 2. I'm going to click line again. 1, -1, and it's going to go to 2, 5. And we're going to look at it. This is going to be an open dot. This one is just for all things greater than 1, so this other point's just going to be an arrow. And then if you notice at x equals 1 on this graph, these are empty, and this one is solid, right? These are functions, so they can only have one value input for 1. You can only have one y for every x. And so, but that is true because it doesn't actually equal these two things. It's only equal where the solid dot is. But do you feel like you kind of got a good run on these now? Like you could probably work with it a little bit better for anyone who's been struggling with it. There's a lot of people not on camera right now. If I can't see you, you aren't on camera. So, all right. Well, for those of you who got it, great. I'm going to stop the recording now and I will post it so you can go back and